Welcome to my presentation. My name is Mohebi from the University of Padua. In this presentation, I'm going to talk about the scheduling and resource allocation in the IEEE 802.11Ad and AY standards. First, I will give you a brief introduction about the topic, and later on I will discuss the challenges and give some research directions that we are currently working in our research group. Wi-Fi is a very popular technology that these days can be found in everywhere. The IEEE 802.11Ad amendment standardized communication in 60 GHz in unlicensed band as an answer to the increasing demand for higher data rates, which can provide data rates up to 6.7 gigabit per second. Its successor, the 11AY standard, will be standardized by the end of this year, and by adding new technologies like as multi-user MIMO, channel bounding, and using higher order modulation can provide even higher data rates, which pave the way for applications like as the wireless docking, ultra HD video streaming, wireless augmented and virtual reality services. In the 11AD, the stations divided the surrounding area into sectors to simplify the beam management procedures. Also, the time is divided into some intervals, named beacon intervals, typically around 100 milliseconds. Each beacon interval consists of a beacon header interval, which mostly used for network management and configuration operations like as beamforming training, network announcement, and scheduling. Also a data transmission interval, which used mostly for actual data transmission and can consist of any combination of CBAPs and SPs. The CBAP, or contention-based access periods, follows the rules of enhanced distributed channel access, in which the stations compete to each other to achieve the channel time before being able to transmit their own data. On the other side, we have the scheduled service periods, in which the channel dedicated to a pairs of stations which can be transmitted over a contention-free channel. To guarantee the quality of service for the sensitive applications, 11AD uses the scheduled service periods on top of the access categories that introduced in former versions of Wi-Fi's like as 11E. On the other side, the non-quality of service traffics can easily transmitted over the contention-based access periods. From one perspective, we can divide the resource allocations into two sub-problems. First, from the station sides, which the problem is to translating the traffic information into the desired allocation parameters, which expressed using the TSPEC elements. And in the access point side, the problem is efficiently scheduling the data transmission intervals based on different factors like as resource availability of resource and other performance matrices. Historically, the scheduling algorithms are mainly based on heuristic, which unfortunately they are not scalable and mostly designed for a certain problems. Nowadays, machine learning and especially reinforcement learning successfully applied in solving advanced control problems, even in telecommunications, by the emerging the self-driving networks, in which the networks learns from data how to operate instead of using the manually designed protocols, which can be optimized and in some cases replace the legacy scheduling algorithms. In the rest of my presentation, I will discuss about the challenges and give some research directions. The commercial devices for the 11AD are available, but they are costly, and in most of the case they do not provide a full access to low-level functionalities. In the other side, we have network simulators, which provides a very flexible, timely, cost-efficient, and arguably less realistic way to analyze the behavior of the systems. The NS3 module for the IEEE 11AD is publicly available, and in its last version it supports much realistic channel modeling based on ray tracing, but it still missed the scheduling part. For the machine learning tools, we have the OpenAI Gym, which is a popular reinforcement learning toolkit that's already integrated with different machine learning frameworks. OpenAI Gym also integrated into the NS3 under the name of NS3 Gym, which is basically a middleware between the OpenAI Gym and the network simulator environment. As I mentioned earlier, one problem we are facing with is generating the traffic specification element, or TSPEC element, which used by the station to characterize the desired allocation and can be embedded into the add traffic stream requests while stations try to establish a connection with some destinations. The important parameters of these elements are including the allocation duration and the allocation periods in which the allocation repeats. The challenges that we are facing with are the both traffic patterns and the transmission conditions are highly dynamic and rapidly change during the time. We want to maximize the channel usage efficiency while meeting the quality of service required by the different applications. Here, a machine learning, a reinforcement learning agent can quickly adapt itself with the new situation by learning the data, the historical data, and update the traffic specification even before starting the next beacon interval. Using different modulation and coding schemes provides wide range of bandwidth. Because of the characteristic of the transmission over millimeter waves, the classical rate adaptation methods are not feasible for the DMG Wi-Fi, and this can highly affect the system performance. Here, reinforcement learning can jointly apply the scheduling mechanisms with the link adaptations by monitoring the bus channel statistic and the network traffics to optimize the network performance. One interesting applications for the 11AD is the wireless virtual and augmented reality services, which should be considered in the analyzing the performance of the different scheduling algorithms. But the problem is there isn't any detailed AR/VR traffic models in the literature. The cloud gaming rendering services, they are behave similarly, more or less, and we can use this, the gaming traffics to evaluate the performance of different scheduling methods. Or we can acquire the real AR/VR traffic traces. For doing this, we need to acquire real-world traffic traces of AR/VR devices. Later on, we can characterize the traffic patterns and derive realistic traffic models. And at the end, to reach a very much realistic scenario, we can integrate the derived models with the standard scenarios. Okay, in this brief presentation, I introduced 11AD, which enabled the short-range multi-gigabit communication in 60 gigabit bands, 60 gigahertz band, which opened the door for emerging applications like as wireless augmented and virtual realities. The 11AD introduced the hybrid MAC, which increases the complexity of channel access time and the scheduling procedure. We discussed some problems and challenges associated with the channel access in the 11AD and proposed some workflows to tackle these problems. The discussed method can be later transferred to the future 11AY standards. Thank you very much for your attention.